Okay, in this lesson, this is video 5C, you're going to be finding the missing side of a right triangle, and that's with a non-special right triangle angle. So we've been finding sides before whenever it was a 45, 45, 90 or a 30, 60, 90, and that was easy enough for us to do. But this time we're going to be starting with an angle that is not a special right triangle piece and seeing if the ratios that we determined in our last video and in our last practice set are going to be able to help us at all. That SOHCAHTOA idea is really going to come into play in a big way in this lesson. So here we go. The first thing I need to know as I'm finding these missing sides is that I am basically going to be using a function. And a function, you guys, has an input and an output. Basically means you do something to some number, you put that number into the function, and something comes out of it that is basically some sort of numerical combination. Functions can be lots of different things, but for trig ratios, the input is always the angle of the function, and the output is the ratio. So that's really important for us to realize, because as I write the notes for how to find these missing sides, you have to remember that it's a function, okay? So the next thing I need to know and keep track of is, as I am doing and going through these, I need to make sure, first of all, that my calculator, and that's why I've gone and given you a calculator picture here on the side, I need to make sure that my calculator is in the right mode. And that mode is called degree mode. So if we hit the second function, sorry, not the second function, if we hit just the mode key right here on my calculator, and we go in, you'll see a menu that looks just like this. And if yours does not have the setup the way that you see it in this rectangle, you just want to make sure that you use your arrow keys here, left, right, up, down, to get to the degree, and then you just want to hit enter so that this degree part is highlighted. The reason for that is because your calculator has these functions, like we've been talking about, built in, so that if I put in an angle measure, I'll get out the correct ratio from it, but I need to make sure that I'm in the correct measurement mode. So make sure you're in degree mode. And I hope you guys can see, I've told you before to look for them, but right here on your calculator is where you find the sine, cosine, and tangent buttons, okay? So actually I'm going to circle those for you so you don't forget where they are, right in the middle there. Okay, so let's go on and we'll start this example, example 1. And in example 1, my instructions say, find the missing side x, and then round to the nearest hundredth once I've found that side. So it's important, you guys, to begin with that you need to know which angle you're looking at, and you want to make sure that you're always at the labeled angle as far as where you're sitting in the triangle. Remember, we had to identify the correct spot as we were doing that. So what we want to do is we want to take this star here, which is where the labeled angle is at, and we want to make sure we put the labels on the triangle sides that already have measures given. So 7, of course, is the adjacent to that starred angle, or the 36-degree angle that's labeled. And then the x on the other side, even though it's not a number, it is a label, and it's actually what we need to solve for. So we remember that that's the opposite side. So to begin, but you can see that because I have my opposite and my adjacent, then as I think about SOHCAHTOA here, my opposite and my adjacent are these last two letters. And so that means we're going to be working with a tangent ratio as we set up our problem. So we're going to start by tangent, T-A-N, remember, is the abbreviation for that. And then we want to make sure we input into the tangent function the angle that is being referenced in our picture here. So that's going to be tangent of 36 degrees And then we know that that should be equal to the opposite over the adjacent is the tangent, and the opposite is my unknown x, and the adjacent is 7. So I'm going to use my calculator, and I'm going to calculate out tangent of 36 degrees. Now when you do this, your calculator automatically when you plug in tangent, it'll automatically pop open a parenthesis, as you can see there. Whatever comes next, that's where your angle goes. And you can go ahead and choose to close the parenthesis afterwards. Probably a really good habit to get into. So that when I do that, I'm going to get a decimal after I press enter. I'm going to get a decimal that is the ratio of any 36-degree angles opposite to adjacent sides in a right triangle. And that ratio, if we go out to, it's probably a good habit to go out to like 4 different decimal places, is 7265. You always want to go out to more decimal places than we're being asked to actually round to, and we're being asked to round to the nearest hundredth here, so that's what we want to work with. Okay, the next thing is I'm going to have 0.7265, and because I've rounded this, I'm now going to change my symbol here to approximately equals, and we've still got x over 7. At this point, guys, you want to make sure that this decimal over here becomes a proportion, or becomes a fraction, so that I can solve it as a proportion. And then at this point I'm going to go ahead and cross multiply. So keeping my squiggle equals, x is going to be approximately equal to, we're just going to do 1 times x is x, and then the other cross multiplied diagonal there is going to be whatever 7 times that decimal is, 0.7265, okay, whatever that product is. And that product, if I use my calculator, is going to be approximately 5.09. So that's the answer to my first example. Now I have to make sure this makes sense because I want to see whether the 5.09 in the picture really makes sense as far as a final answer goes. Well, if I were to think of what this angle B would be in the corner, I can do a quick subtraction here and take 36 out of the 90 that's left and realize that this is going to be a 54-degree angle if I were to do some quick math. So the question is, as I think about the side that is opposite 36 degrees being 5.09, does it make sense that 7 is opposite an angle that's bigger than that? And of course we know with our side and angle relationships that does make sense. So that's the first example, and then we'll go on to the next one. Remember to pause and go back and relook at any of that you need to. I know it can be a little confusing, so take your time. Okay, as we move down the page here, we're going to go ahead and look at example 2. This time we're being asked to find a missing side x again and round to the nearest hundredth again. So we're going to use that same process. We're going to start by labeling the sides that are given. So again, we're going to put ourselves in this corner right here at angle W, and in reference to that starred angle, or the 63 degrees, my 12 is my opposite, and my x is the hypotenuse. So thinking about SOHCAHTOA, as I think about SOHCAHTOA, I have now opposite and hypotenuse, so that's actually going to give me a sine ratio that I want to be working with in this calculations. And as I look at the sine of 63 degrees is the angle I'm being referenced, I want to make sure that that's again still opposite over hypotenuse, so that's 12 over x. Now you'll notice that the variable this time, x, is placed in the denominator of that fraction. It really doesn't change the process at all, it just means there's one extra step, as you'll see. But as I go ahead and plug sine of 63 into the sine function button of my calculator, my ratio that I get this time is 0.8910. Again, go out to more places than you think you're going to need. Since I rounded it, I can make that approximately equals 12 over x. recall that the last time we had a decimal, we decided to place that over 1 so that it was in a situation where I could really quickly just cross multiply here, and that's what I want to do. When I cross multiply, I get 0.8910x is approximately equal to 1 times 12 is just 12. And then before, when I cross multiplied back here, you guys, when I cross multiplied, I just simply had 1x left over. So as I look at 1x left over here, I don't have 1x left over in this example 2. At this point, what I have is a coefficient in front of my variable. So I just need to remember to do the final step of dividing through by that decimal. And then I will get my x comes out to be 13.47. Always put it back on the picture, make sure it makes sense. If x, which is the hypotenuse, was 13.47, the question is, would that make sense? And I think definitely it would, because as you know, the hypotenuse here needs to be the longest side. And since 12 is a leg, it's got to be at least longer than 12, and so we're in the clear. So there we go. There's our final example that I'm going to show you in the video today, a little shorter than before. But go ahead now and go through question section, the Q question of your WISC, and this time I'm going to have you do on your own example 3. Remember to keep in mind SOHCAHTOA. And please flip over the paper when you guys are done with this example. Pause it if you aren't. One more question I'd like you to think about as we get ready for our next video